All right, these are the answers to page 3 of the review, and we've got a polar equation defined by this. If you were to graph this out, you end up with one of these kind of graphs here with 3 petals on it, and they want us to find the area of one of these petals. So we want to know, when are we at 0? When are we going to start and stop one of these petals? So if we set this equal to 0, what we get is cosine 3 theta equal to 0. And cosine is equal to 0 at pi over 2, at 3 pi over 2, and so on. If I were to take 3 theta and let that equal that, then theta is going to be pi over 6 and 3 pi over 6, which is really pi over 2. So if we go from pi over 6 to pi over 2, that'll be one of these petals. And so I'm going to go 1/2 times from pi over 6 to pi over 2, 7 cosine 3 theta squared d theta. You put that on a calculator, you should get 12.828. All right. So that's our area of one of those. Now, part B says find dr d theta at pi over 4. What does it mean? So dr d theta is just the derivative of this. So dr d theta would be 7 times derivative cosine. So that's a negative 7 sine 3 theta, then times 3. So really this is going to be a negative 21 sine 3 theta. Okay, that's the derivative of r with respect to theta. If I were to put at pi over 4, if I were to put that in and calculate, I get negative 14.849. Okay, so now this is a little bit tricky because that tells you that the distance from the point to the pole is decreasing. But what's tricky about it is that if you were to actually calculate r at pi over 4, you would get a negative 4.950, which means at pi over 4, we're already actually this side of it, okay? You can imagine we're, instead of being on the positive side, we're over here on the negative side, and we're moving in a negative direction away from the pole. So that means that this, what does this negative 14.849 mean? Because of us being on the negative side of that pole, we are moving away from the origin at rate of 14.849 units per radian, whatever the units would be on this, okay? So normally a negative dr d theta would mean we're getting closer to the pole, the distance is coming down, but in this case, it actually gives us that. Find the equation of the tangent there. So I need to find x and y at that spot. So if I were to create an equation for x, r times cosine, and put pi over 4 in, what I'm going to get is 3.5 negative. If I were to put y in there, times sine theta, and try that, I get 3.5. So there's my point, negative 3.5, 3.5. Okay? And then if I find my dy dx, that's going to be dy d theta over dx d theta. So you take the derivative of this using product rule, derivative of this product rule, put theta in, work it out. It's a whole lot of work, and what you end up with is getting just 2 for your answer if you do it correctly. So our equation would be y minus 3.5 equals 2 times x plus 3.5. Now last one here says if d theta dt is equal to 6, what does dy dt equal at pi over 5? So what we want is dy d theta. And so we get that again by taking the product rule of that. Dy d theta would be product rule negative 21 sine 3 theta sine theta plus 7 cosine 3 theta cosine theta. Okay? And if I were to work that out at pi over 4, we would get this as negative 14. So dy d theta is negative 14. Now, dy dt is dy d theta times d theta dt. And we know that because the d thetas would cancel and we'd get dy dt left over. Dy d theta we just said was negative 14. D theta dt was 6. If we multiply them, we end up with negative 84 as our answer. All right. Now we get the first one of the things. I think we're going to actually use this as a different video, so I'll see you in just a second.